Hello students, let's welcome to our YouTube channel Physics for UG. Now in this video we shall start with the part variation of CV with volume. मतलब CV क्या होता है, CV स्पेसिफिसिटी होता है, उसका वेरिएशन वॉल्यूम के हिसाब क्या होगा हम इसको जानना है। तो पहले स्पेसिफिकेट एट कांस्टेंट वॉल्यूम CV equal to delta Q by delta T. What is delta Q? Delta Q is the heat and delta T is the temperature. So del Q by del T at constant volume is the CV. So CV क्या होता है? CV specific होता है. Specific heat is of two types. One is specific two types. One is CP and another is CP. CP का मतलब specific heat at constant pressure and CP का मतलब specific heat at constant volume. तो CV इक्वल टू डेल क्यू बाई डेल टी एट कॉन्स्टेंट वॉल्यूम विच इज इक्वल टू टी इंटू डेल्टा एस बाई डेल्टा टी एट कॉन्स्टेंट वॉल्यूम. सो वी यूज हियर दिस फॉर्मूला डेल्टा क्यू इक्वल टू टी डी एस और डी क्यू और सिमिलर टू डी क्यू इज इक्वल टू टी डी एस. दिस इज द सेकेंड लॉ ऑफ thermodynamics. We use this law here, okay, because this dq is equal to tds. Next part, so delta s by delta t at constant v will be how much? So this part, this right side part is taken here, is kept here, and we can write this t is divided with the left side, so that will be cv by t. So let name is as equation 1. Now we know in Maxwell's relation there are four relations. Actually there are four relations. We use the second relations here. For the second relation, delta s by delta v at constant t is equal to delta p by delta t at constant v. This is the second Maxwell's relation. Okay, now differentiating this equation with respect to t, temperature differentiating. सो लेफ्ट साइड राइट साइड को हमको डेरिवेटिव करना है विथ रिस्पेक्ट टू टी. सो डेल बाई डेल टी ऑफ डेल एस बाई डेल वी टी, दिस इक्वेशन फ्रॉम दिस इक्वेशन एंड फ्रॉम दिस पार्ट टू दिस पार्ट, डेल बाई डेल टी ऑफ डेल पी बाई डेल टी एट कॉन्स्टेंट वी. नेक्स्ट पार्ट विल बी del by del t of del s by del v, this much, and del by del t of del p by del t at constant b. Simple, we have written del by del t. So next part is, this is del by del t and this is del by del v. We can interchange both because derivative first with respect to v and then with respect to t is same as derivative first with respect to v and then with respect to t. This is the property of partial differential equation. So you can write del by del v of del s by del t at constant v at t constant. Next part, right side में क्या होगा, del by del t of del p by del t, that is double derivative. So del square p by del t square at constant volume. So next line, del by del v of cv by t at constant t, because del s by del t, this part is equal to cv by t, that is from equation 1, del s by del v from equation 1. So cv by t, which is equal to del square p by del t square constant b, same as both line are same. So next part equal to 1 by t. So this, from this line, temperature T is constant, so we can take this T outside. So this is 1 by T is equal to del Cv by del V, del Cv by del T at constant T is equal to del square P by del T square at constant V. So next part, this T in the left side is taken to the right side, multiplied. So del Cv by del V at constant T equal to T into del square P by del T square at constant V. So what will be there? If we write this del as delta, this is also change, this is also change. Okay, that is delta, we replace this d del as delta symbol. So what will be this part will be delta CV, and this dV is taken to the right side. It will be multiplied with this equation. So here it is written delta V. So this part is delta CV is equal to T into same part d square P by dt square. We can write D as del d square P by dt square into delta V. This is the variation of CV with volume. That means delta CV is the specific heat at constant volume, and this is delta CV means variation of CV with respect to volume, because this is delta V. So from this line we can write delta CV varies with delta V. How? Delta CV is equal to T into d square P by dt square into delta V. So in the next part we shall discuss the similar part, that is variation of CP. Variation of CP with pressure. What is CP? CP is basically similar to CV. CP is the specific heat at constant pressure. So specific heat at constant pressure is given by CP equal to delta Q by del T at constant P, which is equal to T del S by del T at constant P, because we use dQ/dT. This is the second law. This is second law of thermodynamics. We use this part here. Okay. So what will be del S by del T? This part. So this part will be, so T is divided in the left side. So CP by T. So this take as equation 1. Now here we use Maxwell's third thermodynamic relation. We use third relation. In the previous part we used the second relation, and in this part we use the third relation. This one is the third relation. Del S by del P at constant T equal to minus del V by del T at constant P. Then what to do? Then differentiate the equation similar as previous one. Differentiate with respect to temperature T. So what will happen? The equation, write del by del T in the left side and put del by del T in the right side. So what will be in the right side part? If you write del by del T here, so this part will be double derivative. That means del square V by del T square are constant P. So next part in the left side, this is del by del T and del by del P. We can interchange both derivatives, because we know in mathematics del square any function with respect to del x del y is equal to del square f by del y del x. डेरिवेटिव with respect to फर्स्ट करके बाद with respect to y करना और फर्स्ट y करके बाद x करना दोनों सेम होता है. इसीलिए del by del p of del s by del t at constant p. So this part we can just interchanged equal to minus del square v by del t square at constant p. The same part. Next part is del by del p of Cp by T, because this is from equation 1. Del S by del T at constant P is equal to Cp by T. You can check the equation 1 from this part. That will be minus del square V by del T square at constant pressure. So del Cp by del P, this T is constant, so this can be taken to the right side. Okay, so T is here. T equal to del Cp by del P equal to minus T into del square V by del T square at constant P. So what will be delta Cp? This del Cp we can write delta Cp means variation of Cp, and this delta P is taken to the right and it multiplied in the right hand side. So minus T into del square V by del T square delta P. So this formula actually the variation of Cp with pressure, because this part delta Cp equal to minus T into del square V by del T square delta P. This is the variation of Cp, and the previous one is the variation of Cv with volume, and this one is the variation of Cp with pressure. Thank you. If you like this video, then subscribe and share this channel. Thank you.